Good morning, everyone. I think we'll start off. The others will come when they come. Am I audible to everyone?
Yes, sir.
Okay. So this is the last part of your dynamics lab, other than your experimental part. So today I'll be teaching you guys how to do Fourier transform. Okay. So why is Fourier transform important? So first thing you need to understand is whenever we record earthquake data or response of a building to an earthquake, we get something called as a time domain data. Okay, so your amplitude of motion or your amplitude of your building with respect to time, and most often this time domain data that we get is not really useful to us in any way because we need it as a function of the frequency of the building. Okay, so whenever we get some data, we'll have to convert your time domain data to frequency domain data in order to get the natural frequencies of the buildings, etc. So if you're modeling the building on software, well and good, you get the more natural frequencies and the mode shapes directly. But in case you do not have the capabilities or the necessary tools to sit and model the building on a software and Obtain, but you have a live physical model, okay, made of some material that exists, you can still get the natural frequencies. Okay, how? So you do something called as a free vibration test. Okay, so a free vibration test will look something like this. One second. Can you guys see this model? It's very similar to ours. Okay, so it is a 3-story model. It is mounted on a rock solid base. It does not even have to be on a shake table. Connect 3 accelerometers, okay, at 3-story levels, and simply give a manual excitation at any one of the story levels. Just push it and leave. Once you push it and leave, it will start automatically vibrating, correct? And this amplitude of motion will continuously decay over a period of time. So this data that we get is called a free vibration. Why is it called free vibration? I'm only giving an initial condition here. The initial condition can either be an initial displacement or an initial velocity. Okay, that is all. It is not a force vibration problem. There is no continuous harmonic motion that is acting on the building. You strike it, leave, okay, until it decays and comes back to its original position. Free vibration test. So you'll have to do this for all the models. Mount it on a rock solid base, use clamps or whatever to restrict the movement of the building. Connect accelerometers. Here they've said oscilloscope. Okay, this is a little predated. We'll use accelerometers and a data acquisition system. Okay, so connect accelerometers and collect data on the data acquisition system. Once you collect the data on the data acquisition system, it looks something like this. Okay, so this is the x-axis, which is the time in seconds. Okay, which is the time, and you'll have the acceleration data from 3 channels. In this particular problem, it was a 3-story building. I'd use 3 accelerometers, so have 3 channels data. Okay, so this can be the first floor, second floor, third floor, the acceleration values. Okay, now the key thing to notice here is the x-axis is not actually in seconds, but it is in milliseconds. Okay, so this is basically 1,000th of a second. And so judging by the unit here, we can guess what the sampling rate is. Okay, this will come in handy at a later point. Sampling rate andre, in 1 second, how many readings is it capable of taking? Okay, so if one reading is 1 millisecond, in 1 second I have 1,000 readings. So the sampling rate is 1,000 per second. Okay, remember this. This is important. Sometimes you don't really need that accurate, but it's fine. The more accurate it is, the better it is. It's just that you'll have a lot of data points. Like for example, in this particular problem, we have about 36,472 data points. Okay, it will just mean that the results that you get will be more accurate in the end. Okay, so next, how to assess this data and get the frequency values of your building. So before I start off with an actual building, I have made one explanation sheet so that it is easier for you guys to understand with normal sinusoidal values. So let's try and see that first. Okay, instead of using time history data of a regular building, what I've done is I've generated signals of my own. Okay, so if I want a sinusoidal curve like this, how do I get a sinusoidal curve or a single degree of freedom system? What is the equation of motion? it is, say, x is equal to a sine omega t something. Okay, where a is your amplitude, sine is the sinusoidal function, omega is the frequency of motion, and t is your time in second. Okay, so I've done the exact same thing here. This should actually be centisecond, not millisecond, because nano sample rate 1 in 100 ತಗೊಂಡಿದ್ದೀನಿ. Okay, so centisecond meaning in 1 second I'm taking 100 readings. So my x-axis is technically 1/100th of a second. So first reading is at 0.01 second, 0.02 second, 0.03 second. Correct? Next, what I've done, I've generated my own signal. Okay, let's call the first signal as T1. For first signal, I've used the same formula, another a sine omega t. Okay, so in this case, if you can you guys see what the numbers are on the screen?
Yes, sir.
Yes, sir.
Okay. So the amplitude happens to be 5 in this case. This is some random number. Okay, you can give anything for your understanding's sake. Next, sine of omega. Omega is what? 2 pi f, correct? So I've chosen the frequency to be 2 hertz. So 2 hertz is the frequency. 2 hertz into 2 pi will give me omega, which is 2 pi f, into my time t. Okay, my x-axis. So this will give me the y value at that instant of time. Okay, and then similarly, I've just dragged it up to about 200 values, I think. Okay, that is all I'm taking for this explanation sake. 200 values. 200 values, 2 centiseconds. So the overall time is 2 seconds. From here to the end of the graph will be 2 seconds. Okay. Next, I've generated a signal, 10 sine omega 5t. Okay, so the amplitude is 10. The frequency is 5 hertz. Omega is 2 into pi into 5 into the same time axis again. The last frequency I have taken is 15 is the amplitude and the frequency is 10. Okay. And the frequency is 10. Next, what I have done, for your understanding's sake, I told you, when I take a 3 degree of freedom system, it is basically 3 single degree of freedom systems mounted over one another, correct? So to sort of mimic the same thing, I've taken 3 individual frequencies, T1, T2, T3, and I've made a new frequency, T4, which is the algebraic sum of these 3. Okay. Here I've gone with algebraic sum. You can do the average, you can do geometric mean, you can do algebraic mean, it doesn't matter. It is just one way of generating a new frequency. Okay. So in case of a real building, it will not be as simple as simply adding the 3 natural frequencies. Okay, it is much complicated. What I'm trying to say is this function can be anything. You can still arrive at these 3 constituents of this by doing Fourier transform. I'll teach you how. Okay. Next thing is very, very important. If you want to take a pen and write down this step, you'll have to calculate frequency. Okay. So be it either on Excel or on Matlab, when you're doing Fourier transform, the results that you get after FFT is not directly in hertz. Okay, it is in something called as bins, BINS. It is a random dump value okay, variable. It does not really have any units. So what we need to do is we'll have to generate the x-axis for the y-axis that we obtain. Okay, this is very simple. The formula for getting frequency is your time in centiseconds, okay, or whatever your x-axis was, okay, into the sampling rate. Okay, so in this case, the sampling rate was what? If I've taken 100 per second, the sampling rate is 100. Okay, so this is 100. So this is 100. This is very important. Sampling rate divided by the total number of readings that I have. Okay, so in this case, the total number of readings is how much? 200. Okay, so this is very important. So how do you convert your time to your frequency or your frequency axis? So your time in whatever seconds, centiseconds, milliseconds, whatever you have, into sampling rate divided by total number of readings that you have. Okay, once you do that, you get the frequency plot. Okay, next, how do you convert frequency in hertz to frequency in radians per second? Simply multiply it by 2 pi. Okay, so f into 2 pi, you'll get this value. So you can either plot using this or plot using this. It won't really make a difference in the end. Aita? So my suggestion is, once you get the data from the data acquisition system, this step, okay, yado, this finding out the frequency step, finish it off in Excel only. Don't take it to Matlab and then try doing it there. It will save a lot of headache. Okay, so if this is the data that I get from a data acquisition system, I'll get 4 columns. One is the time column, the other 3 is the channel data. So here I've taken the liberty of already calculating the frequency. Okay. So frequency is what? My time data, okay, into my sampling rate. So in this case, I told you 1 second we'll have 1000 samples. Okay. So into 1000 divided by total number of readings. I just showed you we have 36,472 readings. So that will be the denominator. So has everyone understood how to convert time to your frequency axis?
Yes, sir.
Okay, so time into sampling rate divided by total number of readings. Remember this. Okay, that is all. Excel alli neenu madastilla. So if you actually go on YouTube and search, there is a way to perform Fourier transform on Excel as well. Okay, you'll have to just add one, enable one add in. You can do it. But the disadvantage with doing it on Excel is the number of data points that you have has to be a multiple of 1028. Okay, so 1028 or 2056 or what is next? 4092 something. It has to be a multiple of that. Otherwise, it does not do analysis. Okay. And since it is a slow software, it will take a lot of time to run and give you the results. So my suggestion is when you're doing the Fourier transform, shift to MATLAB. It is very, very simple. Okay. So I'll just show you how to do it. Let me clear everything once again. Okay. Can you guys see what I'm typing on the screen as well?
Yes, sir.
Yes,
Let me delete all the variables. 1 second. Okay. Next, what you can do is this Excel sheet that you have. Okay. You can. I'll just save this 1 second. Save as. Desktop. Okay. Whatever Excel sheet you've just generated, simply drag it. Okay. 1 second. Okay. Drag it, and you'll right inside workspace and kanastidya. Here.
Sir.
Okay. Drop it there. 1 second. Idu yako hang ಆಗ್ತದೆ. Okay, can you see this? If you drag and drop, it will take 1 minute, but wait. Okay, you get a pop-up table like this. When you drag and drop data into MATLAB, you get a table like this, import madake. Or inversely, you can just go here and you can import a file here. Okay, in new hogbittu, there is an option called import the Excel sheet. Ivaga, the next step is key, import, remember, once you get this import table, illi by default, this output type will be table. Nange, I don't want this in table format when I import it into MATLAB. Change it into column vectors. When I change it into column vectors, what it will do is it will convert each of these columns into a separate array list that I can use individually. Okay, important. Remember this. What did we do? Drag drop the Excel sheet or use the import function. Okay, once that is done, go here, drop down menu. It will be in a table format. Change the table format to column vectors. Okay, once that is done, this tick mark here which says import selection, click on that. Now, if you see on the right hand side, I get all the variables that were there. Okay, in the Excel sheet in one row vector. Okay, so I can use the same plot function here to show you how the graph looks. 1 second. So what should my x-axis be? So you guys know how to plot graph on MATLAB. It is simply plot, open bracket, whatever my x-axis. In this case, my x-axis is my time in centiseconds, comma, my y-axis will be one of those, acceleration data. So in this case, I'll plot T1. Okay, so if I do this, I get a graph like this. So if I remember in the Excel sheet, I'd given the frequency of the first curve to be how much? 2 hertz. Okay, 2 hertz andre in 1 second. Okay, what is wrong? CS 1 second. Plot S comma T1. Okay, see here. So in 1 second, I'll have 2 entire wavelengths. So from here to here is 1, from here to here is 2. Okay, So in 1 second, 2 entire full waves. So frequency is what? 2. Similarly, if I had to plot the other things, you'll get a graph. So what I'll do is I'll plot all three together. So the syntax is same, and you can plot all three together as well. So T1, S, T2, S, T3. Okay. So doing this, what it will do, it will plot all the three graphs together. Aita. So the graph is here. So if you can see, they're in three different colors. Okay. And I had given three different amplitudes and three different frequencies. Correct?
Yes, sir.
Okay. So these are the individual waves. Now the net summation of these three waves, I had called it T4 alva. Plot that and see how it looks. S, T4. So this is how it looks. Okay. When I merge all the three waves together, it looks like this. Now looking at this wave alone, can I tell what the three constituent frequencies are? No, it is not possible. Okay. So Aditya, I'll have to do something called as Fourier transform. So before I do it on, this merged value of thing, let me do it on something simpler first. Okay. If I got T1 game, we know what is the frequency. What is the frequency for T1? 2 Hertz, correct? So if again, I'll define a new variable, capital T1 anta. Aita? T1 is equal to, follow the syntax, FFT. Okay. Open bracket, variable name of the pre-FFT value. Aita? So T1, FFT of T1, semicolon, because I don't want it to show the values. Ivaga, when I do FFT like this, at the end of this, the result that I get, unfortunately, happens to be a complex number. Okay. You guys know what a complex number is?
Imaginary number also.
Correct. There will be one real part and one imaginary part. I think I'll show you a few values. For example, ivaga nan T1 togolana. T1, let's say I'll show you values from say 10 to 20. Okay. So T1 values from 10 to 20. If you look at all these numbers, these are complex numbers. It has a real part and it has an imaginary part. Nange beda, I don't want to deal with complex numbers. I want to convert this to a real number completely. So how do I do that? Ili T1 idya. I'll define a new variable called absolute T1. A. Okay. A T1. Okay. This is absolute T1, meaning I'm converting a complex number to a real number. So the command for that is ABS. Okay. Directly of whatever the previous variable was. Say T1. Okay. Enter. Ivaga, what we'll do, we'll compare the same set of variables. 10 to 20 madidvi. Now I'll take the same variables after conversion. Okay, AT1 of 10 to 20. 1 second, let's see. AT1 of 10 to 20. Now all this complex numbers should have turned into real numbers. That is all. Aita, you understood how we did that? Okay. Next, what we do, we've already performed Fourier transform. Now I want to plot my frequency domain plot. For that, simply use plot. Now Excel sheet, you remember we had converted time to frequency. Okay, I had saved it in a column vector called freq, F-R-E-Q. Okay, so that will be my x-axis, comma, my new value after doing FFT and finding out the absolute value will be my y-axis. Okay, so capital A, T1. Aita, if I plot this, I get a graph like this. Okay. So this is essentially performed FFT, converted it to absolute value and plotted it across my frequency plot. Okay. Now key thing to notice about this is all FFT plots are always symmetric in nature. Okay. So about the mid axis, nange left half yenirutto, right half will be exactly the same. Aita. So ingengo ide. So about left half, whatever is true, right half will be the same. So you only have to analyze half the graph on this side. Okay. And in this case, we knew there was only one constituent frequency. So it will have a single peak. If I hope a peak value, find out. In Mailgada, can you see this plus symbol? Okay. That is for zoom function. Just click on that, zoom into this part. What is the value that is shown here? 2. So was 2 Hertz the input frequency that was given? Okay. The other thing, you can also calculate what the amplitude is. Okay, but for amplitude, it's a problem. You remember we're given the amplitude as 5, correct? Okay, so this amplitude factor, you simply divide by your sampling rate. As in 1 second I had 100 samples, correct? Even if I divide by 100, I'll get that 5 directly. Okay, so don't have to worry about that. Clear?
Yes, sir.
Now, since we've done it for an individual thing, can we take the four, all the thing where all the three were over superimposed with each other and check? Okay, so I'll do the same thing again. What will I do? I'll define a new variable called T4, okay, which is equal to FFT of small t4. Okay, small t4 is basically the function that where I had done t1 plus t2 plus t3. Okay, enter. Next, what do I do? This is a complex number. Convert it to absolute. AT4 is equal to absolute of T4. Aita. Now plot again. Plot x-axis will be same frequency, comma. My y-axis will be this AT4. Aita. So this is my graph. So look at this graph now. I told you left half, right half is symmetric. So I only have to consider left half. So I'll do that. I'll take only the left half. Okay. When I look at the left graph, left half, how many peaks are there?
3.
Okay. Each should be corresponding to the one natural frequency of the system. So first peak gana ಎಷ್ಟು ಕೊಟ್ಟಿದ್ವಿ frequency value? 2 hertz, correct? So click on that. So first frequency is 2 hertz. Okay. Is that correct? Now go back. Check what is the value for second frequency. Zoom in again. Click on this. Click on this. Second frequency is at 5 hertz. Correct?
Yes, sir.
Now check for the last one. I think it is fairly obvious. Okay, it'll 10 get peak irado.
Yes, sir.
Okay, so the third peak is at what? 10 hertz. Now go back to your initial Excel sheet and check if the frequency values that you had given is correct. Okay, so first one was 2 hertz. Okay, the second one was 5 hertz. The third one was 10 hertz. Correct? All the three values are same. Okay, next amplitude check ಮಾಡ್ಕೊಳ್ಳಿ. First one was 5, second one was 10, third one was 15. ಆಯ್ತಾ, ಇಲ್ಲಿ ಬಂದ್ಬಿಟ್ಟು ಗ್ರಾಫ್ ಅಲ್ಲಿ ಮತ್ತೆ ಚೆಕ್ ಮಾಡ್ಕೊಳ್ಳಿ. I told you divide this axis by the sampling rate. ಇಲ್ಲಿ 500, 1000, 1500 ಇದೆ. ಎಲ್ಲ divide by 100 ಮಾಡ್ಕೊಂಡ್ರೆ 5, 10, 15 ಬರುತ್ತೆ. First, second, third. Understood?
Yes, sir.
Okay, this was an oversimplification. Okay, in reality, no structure will get such beautiful smooth curves. Okay, it will be a little more complicated. ಇದು ನಿಮ್ಗೆ ಅರ್ಥ ಆಗ್ಲಿ ಅಂತ ನಾನು random ಆಗಿ ಒಂದು simple curves generate ಮಾಡಿದ್ದು. Now can we take one actual building data and check? Understood the procedure?
Yes, sir.
Okay, now let's take one building data. Okay, so building data, this is for a 3 degree of freedom system. I told you, once you get the output out of data acquisition system, it will look like this. Okay, and it will also not be in Excel format. It will be in something called as .csv. Okay, CSV andre comma separated values anta. But you can open comma separated values in Excel. Okay, you can say import ಅಲ್ಲಿ ಅಥವಾ you can only say open ಕೊಟ್ಬಿಟ್ಟು comma separated values ಕೊಡಿ, ಆಮೇಲೆ ಅಲ್ಲಿ delimited ಕೊಟ್ಬಿಟ್ಟು give comma. It will convert all the things into column vectors. ಆಯ್ತಾ? Once that is done, add this column, so which is basically equal to time into sampling rate divided by total number of values. ಇದನ್ನ ಸೇವ್ ಮಾಡ್ಕೊಳ್ಳಿ ಈಗ. One second. File, save as, desktop, save. Aita, once that is done, do the same thing again. What do? Drag drop the Excel sheet into MATLAB. Drag. This thing gets hanged every time. 1 second. Okay, you do that. You'll nodi. Illi data values ಜಾಸ್ತಿ ಇತ್ತಾ 36,000 something ಅಂತ. It is telling opening large spreadsheet. ಒಂದು ಸ್ವಲ್ಪ ಟೈಮ್ ತಗೊಳುತ್ತೆ. but you'll get the same option again. What should we change now? Go here, drop down menu, change table to column vectors. Okay, ಈಗ ಏನೇನ ಜ್ಞಾಪಕ ಇಟ್ಕೊಳ್ಳಿ. MS is my time. Okay, F is my frequency, CH00, CH01, CH02 is my 3 acceleration values. Import. Aita, once this is done, you can see the variables that have come here. Aita, so I need ivaga plot ಮಾಡಿ ತೋರಿಸ್ತೀನಿ how the output data from this is ಅಂತ. Plot CLC plot. My x-axis is my time, which was in yadu milliseconds, milliseconds, comma, which we can plot any channel. They should all look very similar. CH00 ತಗೊಳ್ಳೋಣ ಈಗ. This is how the graph looks. Now look at this graph, compare it to the graph that we were using previously. Okay, ಅದಕ್ಕೆ ಹೇಳಿದ್ರು it will never be that smooth anta. So this is from an actual model, from one of those models in the dynamics lab. ಆಯ್ತಾ? So if you look at the graph here, there are a few distinct features. There is some initial noise thing. Now model ge displacement kodak munchene what we would have done is we would have switched on the system. Adike there will be some initial noise. Okay, this is background data. This is not necessary to me, but even if it is there in the input data, it won't matter to the end results. Aita? Then what has happened at some point, illi yaro hogbittu idan excite madirtare. It is vibrated and it has come to rest over a period of time. Okay, in this particular case, I've only recorded data for about 3.5 seconds, not more. Now close this. Now everyone's understood how you get this graph. Okay, yes, directly from the data acquisition system. Ivaga, idakke I have to do Fourier transform. Okay, nan previous time ali ಎರಡು step ಅಲ್ಲಿ ಮಾಡ್ತಿದ್ದೆ. ಆತರ step wise ಮಾಡೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. You can do everything together. Okay, so for example, idakke what I call it? I call it ATC. Sarina? 1 second. ATC ಅಂದ್ರೆ ಏನು? Absolute Fourier transform ಮಾಡ್ಬಿಟ್ಟು of that channel is equal to, I can do absolute of FFT of CH00, everything in one step. I don't have to, what do you call it? I do it stepwise. I was doing it so that you guys understood. Ashta.
Capital S.
Oh, H is 0. Yeah, thank you. This is correct, right? Yeah. Yeah. So once this is done, your Fourier transform is done. Simply go plot. My x-axis was my frequency f, comma, my ATC. Plot this. You'll get a graph like this. Can you see this graph? We had taken too many data points. So nimge tumba background noise bartida. But again, it is symmetric. So symmetric iradine, I only have to consider 1/2. Correct? So hogbittu and first starting ish matra ತಗೊಂತೀನಿ. Okay, inna ಕಾಣಿಸ್ತಿಲ್ಲ. So I'll select a little more. Okay, can I see 3 peaks now? Okay, so these 3 peaks are corresponding to the 3 natural frequencies of 3 degree of freedoms. Okay, so first peak godre the value is somewhere around ಎಷ್ಟಿದೆ? 1 second. One second. It is somewhere around 0.8. Okay, someone write this down. First frequency is 0.8. Aita. Next, the second frequency is somewhere around 2.77. Aita. Third frequency, I'm pretty sure there is an easier way to get the peak values. Nanagu gottilla ashte. If you guys find out, let me know. The third frequency is somewhere around 4.85 something. Okay, write this down. Now I want to prove something to you after this. Aita. So here in its values, so 0.8. Next one was how much? 2.77. Okay, 2.77. The last one is 4.85. Aita. Close this. Ivaga ನಂಗೆ ಒಂದೇ ಚಾನೆಲ್ ಡೇಟಾ ಇಂದ 3 ಫ್ರೀಕ್ವೆನ್ಸಿ ಬಂದ್ರೆ ವಾಟ್ ಇಸ್ ದ ಪಾಯಿಂಟ್ ಆಫ್ mounting accelerometers at the other 2 story level? Okay, so for that sake we'll check those 2 also. Okay, so I'll call this ATC2 ant kariyana. Okay, this is equal to absolute of FFT of what is that, CH01, correct? Close bracket, close bracket. Now plot this. Plot, I'll click small plot F comma ATC2. Aita. So I get another graph now. 1 second. Okay, you get this graph now. Iವಾಗ ಈ ಗ್ರಾಫ್ ಹೋಗ್ಬಿಟ್ಟು ಮತ್ತೆ do the same thing that we did. Okay, ಇಷ್ಟು ಮಾತ್ರ zoom ಮಾಡ್ಕೊಳ್ಳಿ. Again I get 3 peaks. Can you see the 3 peaks? Okay, so the only difference is ಮುಂಚೆ 3 peak order ಬೇರೆ ತರ ಇತ್ತು. ಫಸ್ಟ್ ಕಮ್ಮಿ ಇತ್ತು, ಆಮೇಲೆ ಜಾಸ್ತಿ ಇತ್ತು, ಥರ್ಡ್ ಒನ್ ಏನೋ ಇತ್ತು. Okay, now the peak sizes are varying, but 3 peaks are still there. Okay, go to the first peak. What is the first frequency value?
0.8.
Previous case ಅಲ್ಲಿ ಎಷ್ಟಿತ್ತು?
0.8 only.
Okay, correct. Now leave it aside. Go to the second peak now. Second peak is where? Okay, this is the second peak. Eshtitu
2.77.
Okay, somewhere close. We have 2.8 now. Okay, so go to the last peak. What was the value previously?
4.85.
Somewhere close to that. Aita, 4.85. So understanding what the significance of this is. ಇವಾಗ ನಾನು ಇದ್ರ ಬದಲು ಚಾನೆಲ್ 3 ತಗೊಂಡು ಅದನ್ನ ಮಾಡಿದ್ರು ನಂಗೆ ಸೇಮ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ವ್ಯಾಲ್ಯೂಸ್ ಬರುತ್ತೆ. ಯು ಕ್ಯಾನ್ ಮೌಂಟ್ ದಿ ಆಕ್ಸೆಲರೋಮೀಟರ್ ಎನಿವೇರ್ ಯು ವಾಂಟ್ ಆನ್ ದ ಮಾಡೆಲ್. ಓಕೆ, ದ 3 ಕಾನ್ಸ್ಟೆಂಟ್ ಫ್ರೀಕ್ವೆನ್ಸೀಸ್ ವಿಲ್ ಆಲ್ವೇಸ್ ಬಿ ದ ಸೇಮ್. ಅರ್ಥ ಆಯ್ತಾ? that was the idea behind asking you to mount 3 accelerometers. It will be sort of a verification. Okay, so when you do a free vibration test, you can mount your accelerometer anywhere you want. Okay, it will still capture the overall feedback of the system, not just limited to that story. So in the test, yadana model kotre, you can mount your accelerometer anywhere along the building. Don't put it on the base. Aita, it will not give you results. At any other story level you put, collect the accelerometer data, do Fourier transform, you'll get 3 frequencies like this. Understood? That is all. Simple.
Yes, sir.
Okay, so if you guys want, I'll share the Excel sheet and the data values I have. Once practice ಮಾಡ್ಕೊಳ್ಳಿ, but do not share this Excel sheet with anyone. Okay, ಕಷ್ಟಪಟ್ಟು ಮಾಡಿರೋದು ನಿಮ್ಗಳಿಗೆ ಅರ್ಥ ಆಗ್ಲಿ ಅಂತ. That is all. So okay, what will happen if I don't convert it to absolute? I'll show you. You get one crazy graph. I'll define a new variable called Q. Okay, I'll simply do FFT of CH00. Okay, so idan madidine. If I do this, I'll get complex variables, correct? Idanna instead of doing absolute value, if I plot it directly, what happens? You get a graph like this, which does not make any sense. Okay, that is why it is important to convert your complex number to a real number. Aita, keep this in mind. So first step, collect data from data acquisition system. Okay, create a new column called frequency. This frequency value will be your time axis into sampling rate divided by total number of readings. Save the Excel sheet, drag drop into MATLAB, convert it to column vectors. Okay, first perform FFT, then convert to absolute values and plot x-axis as frequency, y-axis as the FFT value. Ashte. Any doubts?
No, sir.
Has everyone understood?
Yes, sir.
Okay, so worst case scenario, college start agad late agi experiments e madak aglilla ant helidre, this will be your lab. Okay, I'll give you one model, okay, and one data. For the same model, you'll have to do your matrix method and you'll have to find out the frequencies. Okay, and same model you'll have to model it either on STAD or ETABS and get the frequencies. Okay, and ನಾನು ಯಾವ ಡೇಟಾ ಕೊಟ್ಟಿದ್ದೀನಿ ಈ ತರ ಎಕ್ಸೆಲ್ ಶೀಟ್ ಅಲ್ಲಿ, ಅದಕ್ಕೆ you do FFT and get me the 3 frequencies. Understood?
Yes, sir.
Okay, ಅಕಸ್ಮಾತ್ ಕಾಲೇಜ್ ಸ್ಟಾರ್ಟ್ ಆಗಿ ಲ್ಯಾಬ್ ಏನಾರ ಮಾಡಿದ್ರೆ only the last part will differ. Okay, instead of me giving the Excel sheet directly, you will go to the lab, you will collect this data from the data acquisition system yourself and come and do FFT. Only that step will change. Otherwise, everything else is same. Clear?
Yes, sir.
Okay. With that,
Sir.
I think yes.
Sir, what kind of calculation it will do, sir, while converting complex number to real number, sir?
It is simply square root of a square plus b square. For example, if
Okay.
the complex number is of format a plus ib, okay, my magnitude, say, I'll call it q, is equal to square root of a square plus b square, and the face angle will be tan inverse b by a. Ashte.
Okay.
Yeah. Any other doubt?
Sir, can you share the STAD session also? Recording part?
The video, is it? Okay, I'll check. I think
Yes,
I've recorded
yes.
it. I'll do it.
Yeah,
Anything
yeah.
else?
Because the initial part I missed out. So
Okay, sure.
okay.
Anything else? Anyone else? Any other doubt? We have less than 1 minute left. The group will carry in case this session ends. Okay, with that, I think this will be the last lab. As far as teaching and giving information is concerned, I've done everything. And now you guys only have to practice ashte. We can meet once the college starts. You have my number. You can reach out if you guys have doubt. This Excel sheet and the video, I'll put it up on the Google Classroom. Okay. It will end in about 10 seconds. Thank you all. I hope you guys have understood.